Today, I'm so pleased to have the opportunity to introduce Dr. Chaleece Sandberg, who is joining us all the way from her sabbatical in Australia. And Dr. Sandberg is an associate professor of communication sciences and disorders, linguistics, and neuroscience at Penn State University. And one line of her research focuses on finding ways of optimizing language therapy for adult language disorders, with a primary interest in aphasia. And today she will be talking specifically about the theoretical basis for and impact of AbSANT, the Abstract Semantic Associative Network Training in Aphasia. Thank you, Chaleece.
All right. So hello, good people. I am so happy to be here. I am very honored to be speaking at Moss Rehab. I'm a licensed speech pathologist, and as Sharon said, I'm an associate professor at Penn State. My lab is the Semantics, Aphasia, and Neurodynamics Laboratory, or SAND Lab for short. And I'm just going to be talking today about kind of this main line of research that I've been working on for a while now, looking at word retrieval in aphasia, and specifically abstract word retrieval. So there we go. Now I know many of you are going to have a background in aphasia, so you might already know this, but I'll just go through it for those of you who don't know. Aphasia affects approximately a third of stroke survivors. People usually over the age of 40, because the prevalence of stroke goes up about that time. Over 2 million Americans are currently living with aphasia. And some of the consequences of aphasia include social isolation, depression, and anxiety because of the language difficulty that the people are having. And the most ubiquitous and persistent language problem in aphasia is word retrieval. I really like this image from the National Aphasia Association, where aphasia is when your brain holds your words hostage. And you know, if you've worked with anybody who has aphasia, you've heard a million times the, "Oh, I know it, I just can't say it." So not being able to find the right word during conversation is it's super frustrating, right? It interrupts the natural flow of conversation, and we've all experienced that tip of the tongue state when we can't think of that guy who was in North by Northwest and charade with Audrey Hepburn, and he's got that little divot in his chin. You know the one. If you're all thinking Cary Grant, congratulations. But imagine that happening all the time and with really common words like broccoli, right? So that can really negatively affect somebody's quality of life. So word retrieval is a huge focus in aphasia rehabilitation, and it's a large focus of my work. Now, let's think about the challenge for a second of actually training somebody's vocabulary. So the average vocabulary is 30,000 words. The traditional focus has been on concrete words, and whether training semantically based or phonologically based therapy, there's little transfer to untrained words. And one of the most popular types of semantically based word retrieval therapy is based on its semantic feature analysis. And these therapies that are semantically based are currently showing a little bit more promise, and they're based on the spreading activation model by Collins and Loftus. The idea is that activation spreads from one node to another within the semantic network. The length of the link determines the relatedness of those two words or concepts in the semantic system. And so the nearby concepts that are the most related are going to be active first. And with the training, what we think is happening is that we have this sub-threshold activation, right? That there's a problem with retrieving the word form, or it can be called lexicalization. And so what we need to do is get that activation above that threshold so that the word can be trained. And the way we do this is through training semantic features, right? To just increase that activation within the semantic network. And what we see is that with to really get generalization, we need to be strategic. So this was a study by Kieran, where actually she's done several studies looking at this. But what she found is that when you train typical items within a category, so say we've got the category of birds here, and if you're training things like robin and sparrow, these, they lay eggs, they have a beak, they're small, they have feathers, that kind of thing. But you're not going to get transfer to these kind of characteristic features of these really atypical birds like penguin and ostrich. But if you train the atypical examples, you get those really far out characteristic features of these atypical items, but you also get those features that go for the very prototypical items, right? These prototypical features, things that every bird has. And so this is what helps with spreading the activation to all of the words in that category to help with generalization. But we're still only in the realm of concrete words. So one of the things that we know is that there's something called the concreteness effect. So this is a phenomenon where across a variety of language tasks, people in general perform better for concrete than abstract words. And in aphasia, it appears that abstract words are particularly difficult to retrieve. I do have a student right now who is looking at, she'll be presenting at ASHA, her work looking at concreteness and aphasia, and she's looked at both production and comprehension tasks, and she's finding a correlation between aphasia severity and the concreteness effect. So the concreteness effect is actually larger for people with more severe aphasia. And so when we're thinking about this difference between abstract and concrete words, one model that is handy for thinking about how activation spreads differently for these two types of words within the semantic network and how this can affect word retrieval is the NICE model by Newton and Berry. Now, this model was developed based on behavior observed in a person with aphasia with deep dyslexia. But it's meant to apply to normal processing. The acronym actually stands for normally isolated centrally expressed, which you have to read the article to see like how that all fits together. It's kind of one of those acronyms for acronyms' sake. But what they suggest is that first of all, the threshold for activation of that for lexicalization is higher in aphasia. And so you need more semantic activation to actually get to that lexicalization threshold. And when we think about the spread of activation within the semantic system for concrete words, it's going to be contained to a relatively small group of words so that the activation is going to be really strong and specific. It's going to spread to things that are very similar. When for abstract words, though, or as words get more abstract, the activation spreads out a little bit, and because abstract words are related to so many other things, and their connections with other words are a little bit weaker and a little bit more distant, and so the activation is kind of spreading out rather than causing this really strong activation that goes above the threshold. And so they're less likely to reach that threshold for lexicalization. Another consideration is that the regions that are preferentially active for abstract words, which are shown in the warmer colors here, are the regions that tend to be damaged in aphasia. So just kind of holding on to that thought for a minute. So we've talked about, why we might think about training abstract words based on this idea that they are more impaired. in people who have aphasia. But something else we've been considering is how this traditional focus on concrete words might be limiting communication recovery because they are more required for natural conversation. And so something else to be considering is generalization. Oh, I'm always considering generalization. And we talked about how you can take advantage of the relationship between atypical and typical category members to promote generalization for concrete words. But what sort of leverage does training abstract words give us? So another theory that I really like is this different representational frameworks hypothesis by Crutch and Warrington. And this proposes that concrete words appear to be organized more categorically or taxonomically, so that these similar or like items are grouped together. So this means that if you start with a concrete word, you're most likely going to get spreading activation to similar other concrete words. But abstract words, so everything abstract is in light blue, appear to be organized according to theme or associations. And so this means that abstract words are most likely connected to both abstract and concrete words that are going to be a part of the same theme, or the same context. And so we've kind of leveraged this within the therapy that we're now calling AbSANT. So this stands for Abstract Semantic Associative Network Training. What you're seeing on the right here is a word cloud based on the responses of about 20 healthy participants to the prompt, name as many words as you can think of in the category courthouse. So you can see that there are a lot of different words. The two largest words and the most said words are law and jury, an abstract word and a concrete word, right? So you'll notice that categories like courthouse reflect a theme of what it's like to be in the context of a courthouse. Both abstract and concrete words are elicited, and abstract words that may have different senses or different meanings depending on the context, like argument, right, are going to have a very specific meaning related to the theme of a courthouse. So we have this nice pool of words that we can work with, and we can develop semantic features that capture both kind of generic and specific aspects of meaning to help encourage connections among these thematically related words. So we have done this therapy with a lot of people, actually. We have now published data from 37 participants, 19 of whom have received not only the prescribed abstract training, but also a phase of concrete training as a control. So that's where you're seeing, like in the very far right of this table here. So we had all these different studies that we've done kind of piecemeal. And then we just recently published a meta-analysis where we were able to combine previous work, except we weren't able to use the data from this first study. But we were able to combine the work from the Sandberg and Kieran study and the Sandberg and Gray study. Plus, we had 2 new cohorts. We had 6 people who had completed just one phase, just abstract training, and then another 11 people who had completed 2 phases. So they had both the abstract and the concrete training. And we were able to get a larger variety of people, so a broader range of aphasia severities and aphasia types. And we used interrupted time series modeling to look at so all of this data, and that allows us to more robustly examine more interesting information than just effect size. So I'll explain a little bit more about that in a second. But first, I want to go over the design that we used for all of these studies. So I think I might have a gray box over this little, here we go. So we had 2 trained categories, hospital and courthouse, and then we had 1 category that we're calling the exposed category. And so we, hospital and courthouse were counterbalanced, either between phase 1 and phase 2, and then across participants. And we had a baseline period, and then if the person was just doing 1 phase, we had the 10 weeks of therapy for them, and then the post treatment after phase 1 for people who were doing 2 phases. We did phase 1, then phase 2, and we counterbalanced whether it was abstract or concrete. And then did our post-treatment. We have some maintenance information. We actually didn't include it in the meta-analysis because we didn't have enough people who had done the maintenance probes. So we had 18 people who got 1 phase and 15 people who got 2 phases. So this is the treatment protocol, kind of just a brief overview. So our dependent variable is category generation. It's essentially the name as many words as you can think of in 2 minutes, and we would probe the trained category, the untrained category, and the exposed category. And then we had, once we started therapy, we actually had our very first therapy session we called a brainstorm session. And this is where we were able to come up with some personalized semantic features for each person, which was really useful in, because people have such different opinions and viewpoints about abstract words. So that was kind of a nice way to kind of get at that information. And then we would use that, those personalized features as part of our 45 features. So we had 15 features that were personalized, 15 that were just kind of generic features for the category, and then we had 15 that were distractor features that were things like has 6 legs, right, that would never apply to an abstract word. And then with the treatment steps, we would start with category sorting. So that's the reason I called the church category the exposed category, is because during this category sorting step, they would sort words between either courthouse or hospital and church. So just to give them that sense of what it kind of reinforces that theme for each of those categories. Then we do a feature selection step where they choose 6 features that they like the best for that word. And then they put everything away and we ask them yes, no questions. So that's a feature verification step. And then after that feature verification, we say, okay, is this word abstract or concrete? Can you think of a synonym? And what's the word we're working on again? So that's the recall synonym and concreteness. And then once we have gone through all of the words that we could go through in that session that time would allow, we would spend the last 5 to 10 minutes doing what we called a free generative naming. So this is where they are basically doing the same task that they do in the probes, but this time they get feedback and we can give them cues. So we can, say, oh, that's so great. You said like 5 of the words that we worked on in therapy today. Do you remember that one word that we worked on that you said was, it's frustrating for a lot of people and, happens at the end of a trial, right? Like something that would jog their memory of the word that they were working on. So that gave them kind of practice with the task and practice thinking about, how words are related to each other. We would do our sessions twice a week for 2 hours each session. And I've got an example here of the feature selection step. Can you guys hear that okay?
Mm-hmm. Justice has different meaning for different people. Justice exists only in the mind. Justice applies to defendants.
Yes.
Justice should be practiced by everyone.
Yes.
Justice is available to everyone.
Or we'd like to think so.
Yeah. Justice is necessary or required.
Right.
So that justice is available to everyone, that was one of his personalized features that he chose for that. So yeah, after they choose their 6 features, they put each one into a sentence. All right, so now let's get to the ITS modeling of all of the data that we have so far. So with an interrupted time series, we are measuring changes in the relative likelihood of success from one session to the next, rather than the absolute accuracy of performance. So because of this, they might be really especially sensitive to changes that are small in absolute terms, but are large in relative terms, which starts to be important when you're thinking about abstract word performance. Since this analysis is pretty novel and we don't have any existing benchmarks, especially for abstract word retrieval therapy, we use natural cutoffs in the p-values, the z-values, and the percent change to determine what a meaningful change might be. And so that's what I'll be reporting. So here we have the model predictions for when we combine abstract and concrete word training. The phases are also combined, and so what you see as a baseline and post-treatment is just everything that happened before or after that particular phase, which is why even though we did 5 official baselines, it's an average of 8 before they actually started the phase that we're looking at here. So we looked at 2 different level changes and 2 different slope changes. So for level change 1, what we're looking at is the difference between the last baseline and the first treatment probe. So that means that basically how much change do we see after only 2 sessions of therapy or 1 week of treatment? And we see that there was a nice large jump after 2 sessions for direct training. So direct training is the light blue, but not for generalization or exposure. So those end up being kind of flat here. The first slope change that we're looking at is the difference between the slope in baseline and the slope during therapy. And for the direct training, we see a 9% greater increase over the baseline slope for direct training and 5% increase for generalization. And there was nothing meaningful for exposure. So the gray here, you can see that the line just kind of keeps continuing in the same way. The level change 2 was meant to examine any sort of drop off that you get immediately after therapy ends. And we didn't really see a drop off for any of the conditions. And then slope change 2 is an interesting one because, again, we're looking at the trajectory of treatment and seeing how that differs after treatment is taken away. So for direct training, yes, the slope is different, but it is a relatively flat slope during post-therapy. For the generalization, we see this kind of drop off, but it doesn't drop down to the pre-treatment level. And then for exposure, we just keep seeing this the same trajectory, which I think is interesting. And we can talk more about exposure. We're kind of excited to be able to see these effects of exposure and be able to differentiate that between generalization. All right, so now if we if we look at just abstract training and concrete training, if we separate out those two types of phases. So we see some interesting differences. Although both show a direct training effect, it's more robust for the abstract word training. Both conditions had a 7% level change, but this represented a 4-fold increase for abstract words, but only a 2-fold increase for concrete words. So this is where it's handy to have this kind of relative information. Both conditions showed kind of a similar slope during training, but note that the slope for abstract words is larger. But this is due to the rising baseline for concrete words. So you've kind of got like this interesting thing going on here. So after training has ceased, performance for abstract words kind of drops off a little bit, whereas for concrete words, it stays a little bit steady. And what we're taking this to show is that essentially there's an advantage for concrete words before and after training, right? So before training even starts, people are just kind of improving on the concrete words. After training ends, they're keeping up their level. And so we're just seeing that as, we're taking that as evidence of kind of the concreteness effect, right? That just, even before treatment begins, after treatment ends, like concrete words are just easier to process. In terms of generalization, there is a small but meaningful change for both abstract and concrete words, but there's a more persistent change for the abstract training. So we see the generalization to concrete words being more persistent and staying, this effect is maintaining. And something that's interesting about what's happening with the concrete training is that there's like a little bump for the abstract words when you train the concrete words, but then it falls off. And so nothing here is really really hanging on. So what, just kind of an overall conclusion for this is we're seeing that AbSANT works. It favors abstract word training, and it promotes generalization from abstract to concrete words. So this is kind of a little summary, right? So when you do the abstract training, you get benefit to both abstract and concrete words. When you do the concrete training, you really only get the benefit to the directly trained words. Another really cool thing that we can do with the ITS models is that we can look at predictors of success with therapy. And so we see that aphasia severity is giving us when you have milder aphasia, you have a larger slope change for directly trained items, and you have larger immediate effects of generalization and less withdrawal of these effects. When we look at executive function, we see that people with higher executive function have a larger slope change for generalized items. But there is a decreasing baseline, and so so that could be contributing mathematically to that larger slope for the generalized items. We looked at conceptual semantics using the pyramids and palm trees test, and so the reason we're calling this conceptual semantics is that there were no lexical forms. And so if somebody had stronger conceptual semantics, they had larger immediate and gradual effects for directly trained items, and also an increasing baseline and decreasing treatment slope for generalized items, and an increasing post-treatment slope for generalized items. With the group average, so the way that we look at this in the ITS models, the group average is the 0 point. And so we're looking at like above average versus below average. But when you look just at the group average, there's an increasing treatment slope. And so there's something that the people who had above average conceptual semantics were showing this weird decreasing treatment slope. And so we dug into it a little bit and we found out that that was because those people finished early. So one of the criteria that we have is that if somebody reaches 80% accuracy twice in a row, we stop therapy. And so they're the people who stopped therapy early because they have better conceptual semantics are, so they're dropping out. And so that's why we determined we had this decreasing treatment slope. A very similar pattern happening for lexical semantics. So the way that we're measuring lexical semantics is through subtests of the PALPA, where there's a lexical decision for both abstract and concrete words, and a similarity judgment for abstract and concrete words. So you're seeing larger immediate and gradual effects and less withdrawal for directly trained items. For the generalized items, you see a little bit of a rising baseline, larger immediate effects of generalization, increased performance after treatment ceases, but decreasing slope during treatment. So again, these are people who finished early. So it appears that semantic processing might be especially important for direct training effects, but executive function and aphasia severity might be more dictating the generalization effects. Now, I'm going to just kind of sidestep a little bit here to talk about some work that I've been doing to help address one of the healthcare disparities that we see, which is in services for bilingual individuals with aphasia. So it's generally believed or accepted that over half the world's population is bilingual. We have 54% of Europeans that are conversationally fluent in at least one additional language. 20% of Americans speak a language other than English at home, but only 9% of the SLP caseload is bilingual. So we have a real healthcare disparity, and we have a critical need. So layer on top of this lack of SLPs who can help people who are bilingual, the SLPs who can help people who are bilingual need appropriate therapy materials. And there is a shortage of that. So we've taken the monolingual therapy idea of AbSANT and we've applied it to a variety of languages. We first survey native speakers of the language that we want to treat, and then we create materials based on their responses, like regarding which categories and items are most culturally relevant. And if you want to know more about that, I can talk about that later. But essentially what we are predicting, so here's an example of a bilingual individual with aphasia who speaks Spanish and English. Unlike in American English, courthouse isn't too culturally relevant to Spanish-speaking cultures, and so, but restaurant appears to be. And so that's one of the categories that we train in our Spanish-English AbSANT. So another question is what language to train. And so say we've got a patient who speaks both English and Spanish, but they've been speaking English most of the time living in America. So now that's their dominant language. Do we train English or Spanish? So there might be personal reasons for choosing one language over the other, but we were actually curious what language would have the most bang for the buck. And there's been some debate as to whether treating the non-dominant language or the dominant language was more, would give you more generalization. So we sit on the side of that training the dominant language. We would see the same pattern as monolinguals. So when you train quality, the abstract word, you would get benefit to a waiter, the concrete word in the category restaurant. within the dominant language, but that nothing would really happen with the non-dominant language. But if you were to train in the non-dominant language, so perhaps you train the word calidad, you would get benefit to camarero, but you would also get benefit cross-linguistically to quality and to waiter. So why do we think this is the case? One of the models that helps us to think about what we might expect is the revised hierarchical model introduced by Kroll and Stewart. So in this model, the idea is that there is a lexicon for each language and a shared semantic system that each lexicon pulls from. So when the person is balanced, the connections among these nodes are approximately the same. But when one language is more dominant than the other, so for example, when a second language is learned later in life, you might see something like this, where the connection to the non-dominant language, so you've got a weaker connection to the non-dominant language and to the semantic system. So the idea is that the non-dominant language is piggybacking on the dominant language to get to the semantic system until its connections with the semantic system are stronger. And so if we think about this for therapy, we can imagine that when the dominant language is trained, then the non-dominant language won't really be influenced. You're just kind of strengthening that link between the semantics and the L1 lexicon. But when the non-dominant language is trained, because it piggybacks on the dominant language to get to the semantic system, the dominant language is also activated and therefore benefits. But this is based on normal cognitive control. So we're actually starting to incorporate cognitive control into our interpretations of results when we can. So far, we have 14 bilingual people with aphasia from different races and ethnicities, different languages. Most of the people that we have are Spanish English, but we also have some Polish English and Russian English, Korean English. Essentially, what would happen is if we had a client coming to us that spoke one of these other languages, we would check and see if we had a student who also spoke that language and was willing to do the norming for to find out to get the stimuli to generate words in different categories. And I can talk about the norming later if you'd like. And essentially, when we look at effect sizes, what we see is mostly what we were thinking. So when we train the dominant language, we see that the trained items get better, and then the words that are within the same language, the concrete words, get better. When we train the non-dominant language, we get the directly trained items, the concrete words that are in the same language, and then we also get the direct translations of the directly trained items, but we don't get the concrete words that are related to the direct translations of the directly trained items. And so what we're thinking is that there might be this kind of like two-step process going from abstract to concrete from one language to the other. We're not sure. We're still trying to tease it apart. We're currently subjecting these data to an ITS analysis, but this is what we've got in the meantime with effect size calculations. Okay, so I'm going to switch gears again and kind of let's peek under the hood and see what sorts of neural mechanisms underlie AbSANT and the theories that are supporting AbSANT. So we've had two cohorts now that totaling 28 participants who have completed AbSANT and neuroimaging. Unfortunately, we just wrapped up the data collection for the second larger study, and I don't have the results ready yet. But basically, for both studies, we did a pre-treatment scan and a post-treatment scan. For the second study, we added a scan at the beginning to get a nice baseline before treatment started, and then a scan at the end to explore maintenance effects. During the fMRI scan, we had the people in the study do a language task. It's basically deciding whether a word is abstract or concrete. And the idea was that we could measure their response to both abstract and concrete words. So what I'm going to be showing you today is actually the data that we gathered and analyzed about 10 years ago with a group of 10 participants. And we're just fingers crossed that the current study's results align and kind of amplify these results. So the cool thing about training abstract words and expecting generalization to concrete words is that we already have this evidence that abstract and concrete words are preferentially activate different areas of the cortex. So that's just a little bit of a reminder of abstract words in the warm colors and concrete words in the cool colors. So you've got this nice dissociation. And so what you're looking at in this image is all the red bubbles are increased activation for abstract words after therapy, and all the blue bubbles are increased activation after therapy for concrete words. And this is just when abstract words are trained. So we see that not only is the brain changing for the words that we directly trained, but also for the ones that are just along for the ride. So we found that to be very encouraging. We also looked at changes in connectivity. So basically, whether they added or removed connections, we were really just looking at node degree for this study. So the color scale at the top shows the change in the number of connections, and then the size indicates how many participants actually showed that change. And so the direct training is the abstract words, and the generalization is the concrete words. So just first off, kind of overall impressions. I know these images look pretty similar, but if you look closely, you can see that the direct training just results in more overall changes than generalization, which makes sense, right? That's to be expected. But if you look closely, and when we examine these changes in comparison to changes that occurred in the control condition, what we saw is that left inferior frontal gyrus triangularis seemed most responsive to the abstract word improvement, and then bilateral angular gyrus seemed to be most responsive to the generalization of the concrete word improvement when the abstract words were trained. So we have some ideas for what to expect with our current study. So we'll see if left IFG and angular gyrus are still the stars of the show. Now, at first, it was just kind of satisfying to see that regions that normally process abstract words were changing when abstract words were successfully trained, and to see regions that normally process concrete words changing when we saw generalization to concrete words. But lately, I've been curious about the theories that we're basing this training on. And so I'm just going to bring back this idea of the different representational frameworks hypothesis, which actually hadn't really been tested in terms of what the neural mechanisms would be. So we really don't know if this theory has any sort of neural instantiation. So we did a little bit of digging with the EEG and fMRI. So this is, before I talk about the EEG or the ERP evidence, I just want to explain that we're looking for something called the N400. And essentially, this is a negative going waveform that peaks at about 400 milliseconds. I highly recommend, if you're interested in this, you want just kind of an overview, Kudis and Federmeyer wrote this really nice like state of the science on the N400 in 2011. This is just one of the images from their paper. So they show that the N400 effect topographically occurs in posterior regions. This is what it looks like in the top right corners. You see this kind of difference. And it signals a variety of semantic processing. And so all of these different types of semantic processing, I've circled word association because that's what is most relevant to the task that we did. So it's usually stronger for unexpected items or unrelated items. So essentially, if you see a larger negative peak at about 400 milliseconds, there's more processing required. So we had 24 young, healthy adults do this. They were all within normal limits on the click-it. We had 2 tasks. We had a lexical decision task, and then a semantic relatedness judgment type task. And for the semantic relatedness judgment, we had basically a 2x2 design. So we had related versus unrelated, but that was just to have kind of like a choice for them. But really what we were interested in was this relationship between abstract and concrete and similarity and association. So, and when I say similarity and association, the way that it's defined by Crutch and Warrington, concrete similarity is tangible, directly perceived items that could be grouped under a common taxonomic category. So clearly they are thinking similarity means taxonomic, which makes sense. Abstract similarity, they say items, concepts, and ideas that are not directly tangible but have the same or similar meanings, which could be interchanged in some but not all linguistic contexts. And so, the definition for abstract and concrete similarity is slightly different. It is hard to put abstract words into taxonomic categories. And then concrete association, tangible, directly perceived items that can be drawn together to form a unitary and cohesive real world or imaginary context to which each item contributes some content. So to me, that screams thematic categories. And for the abstract association, it's the same definition, essentially. So based on the different representational frameworks hypothesis, what we would expect is there to be a preference for abstract associated items such that you would see a higher N400 for the abstract similar items, right? Because that requires more processing, it's less expected. And then you would flip it for concrete words where the concrete similarity or items that are kind of taxonomically organized would have a lower N400 than the concrete words that were more thematically organized. All right, so what did we find? Not exactly what we were expecting. So the solid lines are what we're calling the preferred relationship. So abstract associated and concrete similar. So abstract, thematic, concrete, taxonomic. And then the dotted lines are the dispreferred condition for each one. So the good news is that we found it in the right place, right? So topographically, it's in the back where semantic processing should be. And then if we look at the central, the CZ electrode and the PZ electrode, the posterior, that's where we got our significant results. And essentially, what we're seeing is that the concrete words that are paired taxonomically, the most preferred, are showing the lowest N400. So in this graph, negative is up. I've lost my mouse, so I can't like pull. Oh, there it is. Okay. And so that is the least surprising relationship. It requires the least amount of semantic processing. Next up, we've got the abstract associated, so the preferred relationships for abstract words according to the different representational frameworks. And then the two dispreferred types of relationships kind of pattern together. Now, unfortunately, we didn't actually, like what you see here, not all of these differences are significant. So this graded pattern isn't significant. The only significant difference was between the concrete similar word pairs and everything else, basically. So I find this to be an interesting pattern. I feel like maybe with a bit more data, we might start to see some significance to this graded pattern, but as it stands right now, the only thing we can really say is that there's something special about concrete words that are in taxonomic relationships that really resonates. And we're currently analyzing data from people with aphasia in an age-matched comparison group. All right, so for fMRI, what data do we have here? The thing with fMRI that gets a little bit more complicated is that there's some existing neuroimaging evidence that doesn't all totally align, I'll say. So the different representation frameworks hypothesis would say that abstract items are, in an association or thematic framework. Concrete items are in a similarity or a taxonomic framework. If we look at the dual hub theory, which doesn't really include abstract words, so just kind of like set that aside for a second. That's the thematic relationships are in a hub in the temporoparietal cortex, and the taxonomic relationships are in a hub in the anterior temporal lobes. But then when we look at evidence of the concreteness effect from these different meta-analyses, we see that concrete items activate temporoparietal cortex, so angular gyrus specifically, and that abstract items activate anterior superior temporal regions. So that's located in the anterior temporal lobe. So this kind of flips things around for us. This is not like things just don't totally align across the board. And so when we were looking at, when we were thinking about what to expect, we thought, well, what we should do is look at these specific regions, right? Specific regions that are indicated in the dual hub theory, and specific regions that are indicated specifically for or preferentially for abstract word processing and concrete word processing. And so what we have here, we did a region of interest analysis. So first we did a whole brain analysis to look at main effects of concreteness and main effects of taxonomic versus thematic relationships. We did not get any significant results for the main effect for taxonomic versus thematic in the whole brain analysis. We did get really nice concreteness results that aligned with current literature. That's what I was showing you before, where you see the abstract words activating basically the whole language network, but the inferior frontal gyrus and the anterior temporal lobe, the superior portion. And then for concrete words, we see, fusiform gyrus, posterior cingulate, angular gyrus, those kinds of things that you would normally see. And so when we did our region of interest analysis, we were curious to see, what we would see with each of the word pairings. If ATL is preferentially activated for abstract words and taxonomic items, is that what we would see, right? Is the abstract taxonomic would be well represented there. Angular gyrus, would we see concrete thematic being well represented there? And then what would we see in these other regions that don't necessarily fit within the dual hub theory? Would we see differences in taxonomic versus thematic relationships for these abstract and concrete areas? So without further ado, having a hard time moving things around. Okay. So the blue is the abstract thematic word pairs, the orange is the abstract taxonomic word pairs, the gray is the concrete thematic word pairs, and the yellow is the concrete taxonomic word pairs. In these, what we might call disputed regions, the ATL and the angular gyrus, we don't see much difference among the different word pair types. The only difference we see is between concrete thematic and concrete taxonomic activation patterns. And it goes in a different direction than I think you would expect. There's more activation for concrete thematic within the anterior temporal lobe, so it's not higher activation for the taxonomic relationship. What I thought was interesting was when we go down and look at the inferior frontal gyrus and the fusiform gyrus. So inferior frontal gyrus has a lot of things happening here. Overall, we've got more activation for abstract than concrete words, so that totally makes sense because it's an abstract region. But also, this seems to be driven by the thematic word pairs. So there's a larger difference between abstract thematic and concrete thematic than between abstract taxonomic and concrete taxonomic. And the highest activation overall is for abstract thematic. When we switch over to the fusiform gyrus, it flips over to concrete, so concrete higher than abstract, but again, this is driven by words that are in the thematic pairings, which I found to be very interesting. And there's a kind of similar pattern happening with the posterior cingulate precuneus region here. So at this point, we're thinking, all right, so there's we've got this kind of confirmation of these two regions for abstract and concrete, but then we also have this added, like they seem to be paying more attention to these thematic relationships. So kind of a summary, what do we know? We know that training abstract words is efficient, ecologically valid, and promotes neural change. Generalization only goes in one direction, from abstract to concrete words, and the reasons for this are still, we've got some ideas. It's definitely not anything to do with shared features, right? So it's not like the complexity account for atypical items versus typical items. And this was originally what we were thinking. It's generalization would occur because abstract words are more complex. But as I think about this more, it's I think it's less about abstract words being more complex and more about how abstract words are organized within the semantic system. And there might be some relationship there. But you know, stay tuned on that front because this is an active area of research. But something, there seems to be something special about concrete words in taxonomic relationships. And so we can think about that in terms of, like, you know, if you're, maybe this is why semantic feature analysis has been successful when you do train it within a taxonomic relationship, and you do work with these like typical versus atypical exemplars. And then when we look at neural activation, you know, trying to localize what's happening, it seems like left inferior frontal gyrus. So left inferior frontal gyrus appears to, you know, it's heavily involved in abstract word processing. We see that it improves after therapy, or it increases activation after therapy, increases connectivity after therapy, and it seems to be tuned to thematic, abstract thematic representations. And then fusiform gyrus, maybe it's tuned to concrete thematic. So these are the things that I'm thinking at this point, but happy to discuss more. Yeah, so I'm going to keep exploring, but that's what I've got for now. I just wanted to give you some information here. We have just a couple of things. This AbSANT therapy we've got freely available on our website. There are some videos, training videos, and I've got the tutorial. I've got a free version of the tutorial on the website. Further on the page, I've got all the stimuli available. I'm working to get all the bilingual stimuli up on the website. The other thing I wanted to talk about was a new group that I have started in collaboration with some individuals with aphasia. A gentleman who's a Penn State alumnus with aphasia contacted me and said, hey, do you have a support group just for alumni, Penn State alumni? And you have to understand, Penn State has the largest alumni association. I don't know if it's in the US or the world or whatever, but it's huge. And like people like Penn State proud, right? And so on his, with his desire, and I'm helping now to facilitate this Penn State alumni aphasia group. But yeah, it's Ed Nunez and Denise Mendez are the two Penn State alumni with aphasia who are facilitating this group. I'm just there basically for technical support. But yeah, the idea is to advocate for stroke awareness and to support the community, and to have a shared identity where people can talk about more than aphasia, right? They can talk about all the things they remember from being at Penn State as a student. So it's a lot of fun. But yeah, that's it for me. Thank all my collaborators. Thank my funders, and most importantly, all the participants. Any questions?
Hey, Chaleece, it's Sharon.
Hey.
Thank you so much. What a great talk. I have about an hour's worth of comments and questions, but I'll limit myself so other people can have a turn. I was wondering if you've thought at all about potential applications to people with PPA, specifically semantic variant, and potentially capitalizing on the reverse concreteness effect. So kind of treating from an area of potential strength.
Yeah.
And then, either for shorter term gains or longer term maintenance.
I actually have not thought about that, but that's fascinating. That would be a lot of fun to look into.
Yeah. That would be fabulous.
What? Do I need to go closer to it? Is that what? Does this help?
If you sit maybe closer to the owl, I think that helps.
I'm really close to the owl.
Okay, well, we can hear you now, so it's working.
All right, so thank you for the talk, Chaleece. So I have a couple of questions. I understand that the neural substrates for concrete and abstract words are distinctly different. Is that one of the reasons why you think that this is not related to complexity and it's related more to how they are organized?
I hadn't really thought about it in terms of the neural substrates. It didn't seem like complexity could handle all of the different facets of abstract and concrete words and their potential relationships with each other. And I think part of why I started moving away from that complexity idea was because I had such a hard time reconciling the fact that they really didn't share any semantic features. So if you think about the complexity account, so it started out with syntactic complexity, right? So in order for that to work, you had to have sentences with the same types of movement, just one being more complex than the other, right? So like going from, object relatives to passives or something. And then with the semantic therapy based on complexity, it seemed all to be done with semantic features where the atypical items just had these kind of special features that you would train in addition to these characteristic features. So in each case of the complexity account, there's like something additional that you're training, but that you've got this kind of core training that you're also taking care of. And so you're training the complex nature of the items that are being directly trained, but then you're bringing the less complex kind of underlying mechanism along with you. But with the abstract and concrete words, that it just didn't, I couldn't find where the abstract words was like, it's just a little bit, it was like the same thing, but a little bit more. It seemed like it was qualitatively different. And it might have been, yeah, like I don't remember exactly thinking, oh, it's because they're represented separately in the brain. It was, but that does jive.
Yeah, I was thinking about this paper that I read with Bob Bjork on desired difficulty, and he talked about this aspect of how kind of carefully crafted difficulty that really engages distinct processes might be better than just targeting one single process. So I was thinking about in that context. And my second question really was, so when you showed the changes in connectivity data with concrete, with those dots, it seemed that it engaged bilateral networks.
Yeah.
Are concrete words sort of not left lateralized, or they rely more on bilateral?
Yeah. So when we look at the meta-analyses of the activation patterns for abstract and concrete words, it is more bilateral for concrete words. Especially in like angular gyrus.
Thank you.
Yeah, thank you. It looks like so Lena.
Yes, thank you. Can you hear me?
Yes.
Okay, thank you very much for the presentation. I've been thinking about your different theoretical proposals, and I was thinking about this this view of proposed by Haidt and Barsalou about the instantiation principle that says basically it was initially put forward to explain abstraction in general. So not only about abstract concepts, but also about the emergence and the representation of superordinate categories. And the idea is just and so the idea is just that we would represent subordinate categories and more abstract concepts in as an instantiation of exemplars. And so and I was wondering if this could relate. I think the initial paper is from the 80s, but yeah, and I've not thought about that in terms of abstract versus concrete concepts. But I was wondering if this could relate also to some of the results you have. Maybe not all the brain results, but at least part of the behavioral results.
So yeah, sorry, explain a little bit more.
No, the idea, I mean, the idea is that you so when you think about this might be trivial for animals, but when you represent animals, you don't actually represent animals. You represent just a collection of course, more typical exemplars, but you cannot re-represent a subordinate concept. And if you think of abstract concepts actually as subordinate concepts, in a way that justice is not just justice, it's just a collection of other subordinate concepts. And this could also explain also the greater impact of your treatment, and also part of the interaction with thematic and taxonomic processing. So yeah, I'm not sure this could explain everything, of course, but yeah, this might be also maybe a relevant framework to think about these distinctions.
It's a super interesting idea, and I think it's relevant to think about because you know, when you said that, it made me think back to, you know, some of the therapy sessions, and having people insist that the word was concrete because the example they were thinking of was a very concrete example. And so I thought that was kind of a very interesting thing that like kind of fits into what you're saying. Maybe the abstract concepts are just kind of like this this category of events or things that happen that are more concrete in nature that fall under that. Yeah, that's such an interesting
I have
idea.
to think about how this could relate also to the brain dissociation that we see, because in this original paper they didn't talk about, you know, the neural substrate. So yeah, it has to be, you know.
Yeah.
Okay, but yeah, thank you.
I've also been reading Lakoff's Metaphors We Live By, right? And so now I'm in this mode of like, oh yeah, so everything we understand for abstract words is through metaphor, right?
Yeah, thank you for the.
Thank you.
Maybe can I ask a follow-up question a little bit to that? Can you hear me okay?
Yeah.
Okay, great. So when you were kind of describing the intervention that you're using with your aphasics, you know, you used an example of justice, and you noted that like he had picked this concept of like justice is for everyone. And when I was thinking about that, I was really struggling with trying to figure out like what is the connected concept that you're connecting justice to, right? Because it's like not quite like everyone, but you know, so I don't know what.
So so the point is not to specifically link each abstract word with a concrete word. The point is to increase the activation for the abstract words so that it's easier to pull that lexical form out from the system, so that it rises above the threshold. So really we're getting them to think more about the meanings of abstract words to get kind of like jog the semantic network basically. But then the idea is that once they've got that higher activation for that concept, that activation will spread to related concepts, and that the concrete words will be part of the related concept that activation spreads to. So it's going to make it easier for them to also retrieve the concrete words that are related.
Right, but I mean, presumably, even if the concept is not concrete but is abstract, like I still don't know how to kind of think about that concept of the justice is for everyone. As like, what is, you know, again, what are you connecting justice to, even in an abstract sense, that is then going to get pulled along every time you activate justice?
Chaleece, I'm just curious, Chaleece, this was that particular concept, that was one that was participant generated, correct?
Right.
Not one that was experimentally generated.
Right.
Yeah, some of the experimentally generated examples before that, I can't remember what they were, but they were kind of similar in that vein. Of like,
yeah, so there's, like generally considered positive is an idea. Those are some of the general ones that we have. And it's really just to help form kind of a cohesive like concept or meaning, or, you know, base, right, for that word within that context.
Right, but isn't the idea that you're doing that by sort of building up this network of ideas? Or like, or maybe I'm thinking about this wrong, because this isn't really my area.
Yeah.
How do those definitions sort of store?
So the goal is it's not to create a new entry for the word that has all those semantic features related to it. And actually we encourage people to talk about different semantic features for each word each time they practice it. It's to increase the activation for that concept. It's to just get them thinking about the meaning of that word more. And And then once they've got that meaning more active, then it can spread to other concepts. We're not thinking about it in terms of like, you know, how you these like corpus models, right? Where like the word is defined by like all the semantic features that fall under it. It's more of, okay, so here is the word, this is how I talk about the meaning of the word. And it's that whole concept is more active for the person. Does that, I don't know if that's helping.
There, I'll think about it. Okay.
Okay. John.
Thanks. That was really an interesting talk, and I guess this might be a little bit responsive to Aaron's point, but I mean, it seems to me that that one of the most interesting things that you talked about was the fact that the various kinds of evidence that abstract words are organized in a more thematic rather than taxonomic way, and that, you know, it's easy to just say, oh well, we need to learn new words. What's the best way to learn new words? But when you use words in different ways and when they're organized in different ways, probably you need to reacquire them in different ways as well. And so and as soon as you sort of talked about that evidence, all the intuitive examples of why that would be come to mind. I mean, it's so easy to check off. We would all come to consensus about the features, yes or no, that characterize this or that animal or plant or piece of furniture or whatever. But, you know, what are the features of justice, yes or no, that we would all check off, et cetera, et cetera? How does it overlap with truth, yes or no? You know, it just doesn't work at all in the same way, it seems.
No, it sure doesn't. And, you know, having experience doing both kinds of therapy, the abstract therapy is, it's challenging, but also fun because there's a lot of conversation that goes along with it. And you start to question like your own belief system about the meanings of words, right? Because you have this discussion and we encourage them to, like, if they, you know, choose a feature and you're like, oh, well, that doesn't make sense to me. You know, we say, well, tell me why you picked that. Like, give me a rationale, like convince me that that is a feature for that word. And that's where the fun comes. Like it's really interesting to see the explanations that people come up with and the different viewpoints that people have. And yeah, that's one aspect that I really have enjoyed.
So Chaleece, do you think that to some extent abstract representations are a bit more flexible and then
Oh yeah,
so idiosyncratic, and that level of idiosyncrasy is more permissible? So
yes, yeah, exactly. That I like the way you worded all that. Yeah.
I just I think this is so important. You know, we hear from people with aphasia so frequently that they don't want to just talk about basic needs and wants. They want to, you know, be able to have conversations about complexity, and they want people to allow them to have those conversations. And so giving people tools to do that is really important.
Yeah, and it's so it can one thing that I've noticed in like training students to provide the therapy is that it can take on a different flavor, and it really does. You need therapeutic alliance for this therapy, and there needs to be this acknowledgement of competence and respect, and otherwise you start to sound like, as the clinician, like demanding and like you're questioning their intelligence, right? If you don't agree with whatever feature they've chosen, or however they're, you know, talking about this word. And so that's been really eye-opening too, is to find ways to let people, especially people who need a lot more conversational support, to be able to express what they mean without having the clinician kind of being overbearing and forcing the client into their perspective of what that word means.
Thank you.
But a lot of like stories, like personal stories, start to come out, which is fun.
Right. Which, you know, potentially the more relevant you make the treatment, the more salient and potentially the more effective.
Yeah, yeah. And we've
I mean, there's nothing wrong with also tapping into episodic memory to help support.
Right.
Yeah.
And you know, for experimental purposes, we were sticking with, you know, these few categories. But when we did the norming, we actually have like 10 different categories that people have generated words for. It's just we chose the ones that had like the most balanced list of abstract and concrete words in terms of like frequency and familiarity, like all this kind of stuff, you know, they do experimentally. But we had one client who finished the therapy and loved it so much that she contacted me around Christmas time and said, hey, do you have a Christmas category? And I said, I don't, but you can create one. Like if you want to work with your family to create, you know, the words that, like the abstract words in the Christmas category that you want to work on. Yeah, so that was kind of fun.
I don't know if anybody else has any questions or comments. But if not, thank you so much for joining us after your
My
long
pleasure.
travels. It was wonderful.
Just a little bit jet lagged.
Yeah, yeah. Thanks again.
Thank you. This was really energizing for me. It was a lot of fun, so I really appreciate it.